A wind farm or wind park is a group of wind turbines in the same location used to produce electricity. A large wind farm may consist of several hundred individual wind turbines and cover an extended area of hundreds of square miles. But the land between the turbines may be used for agricultural or other purposes. A wind farm can also be located offshore. Many of the largest operational onshore wind farms are located in Germany, China, and the United States. For example, the largest wind farm in the world, Gansu Wind Farm in China, has a capacity of over 6,000 megawatts of power in 2012 with a goal of 20,000 megawatts by 2020. The Alta Wind Energy Center in California, United States is the largest onshore wind farm outside of China, with a capacity of 1,020 megawatts. As of April 2013, the 630 megawatts London Array in the UK is the largest offshore wind farm in the world, followed by the 504 megawatts Greater Gabbard Wind Farm in the UK. There are many large wind farms under construction, and these include Sinus Holding Wind Farm, Lynx Wind Farm, Lower Snake River Wind Project, MacArthur Wind Farm. Design. As a general rule, economic wind generators require wind speed of 16 km per hour or greater. An ideal location would have a near-constant flow of non-turbulent wind throughout the year, with a minimum likelihood of sudden powerful bursts of wind. An important factor of turbine siting is also access to local demand or transmission capacity. Usually sites are screened on the basis of a wind atlas, and validated with wind measurements. Meteorological wind data alone is usually not sufficient for accurate siting of a large wind power project. Collection of site-specific data for wind speed and direction is crucial to determining site potential in order to finance the project. Local winds are often monitored for a year or more, and detailed wind maps constructed before wind generators are installed. The wind blows faster at higher altitudes because of the reduced influence of drag. The increase in velocity with altitude is most dramatic near the surface and is affected by topography, surface roughness, and upwind obstacles such as trees or buildings. Typically, the increase of wind speeds with increasing height follows a wind profile power law, which predicts that wind speed rises proportionally to the seventh root of altitude. Doubling the altitude of a turbine, then, increases the expected wind speeds by 10%, and the expected power by 34%. Individual turbines are interconnected with a medium-voltage power collection system and communications network at a substation. This medium-voltage electric current is increased in voltage with a transformer for connection to the high-voltage transmission system. Construction of a land-based wind farm requires installation of the collector system and substation, and possibly access roads to each turbine site. Onshore installations. The world's first wind farm was 0.6 megawatts, consisting of 20 wind turbines rated at 30 kilowatts each, installed on the shoulder of Crotched Mountain in southern New Hampshire in December 1980. Onshore turbine installations in hilly or mountainous regions tend to be on ridgelines generally 3 kilometers or more inland from the nearest shoreline. This is done to exploit the topographic acceleration as the wind accelerates over a ridge. The additional wind speeds gained in this way can increase energy produced because more wind goes through the turbines. The exact position of each turbine matters, because a difference of 30 meters could potentially double output. This careful placement is referred to as micro-siting. Offshore installations. Europe is the leader in offshore wind energy, with the first offshore wind farm being installed in Denmark in 1991. As of 2010, there are 39 offshore wind farms in waters off Belgium, Denmark, Finland, Germany, Ireland, the Netherlands, Norway, Sweden and the United Kingdom, with a combined operating capacity of 2,396 megawatts. More than 100 gigawatts of offshore projects are proposed or under development in Europe. The European Wind Energy Association has set a target of 40 gigawatts installed by 2020 and 150 gigawatts by 2030. As of September 2013, the London Array in United Kingdom is the largest offshore wind farm in the world at 1,000 megawatts, followed by Greater Gabbard Wind Farm also in the UK. Offshore wind turbines are less obtrusive than turbines on land, as their apparent size and noise is mitigated by distance. Because water has less surface roughness than land, the average wind speed is usually considerably higher over open water. Capacity factors are considerably higher than for onshore locations. The province of Ontario in Canada is pursuing several proposed locations in the Great Lakes, including the suspended Trillium Power Wind 1 approximately 20 kilometers from shore and over 400 megawatts in size. Other Canadian projects include one on the Pacific West Coast. As of 2010, there are no offshore wind farms in the United States. However, projects are under development in wind-rich areas of the East Coast, Great Lakes, and Pacific Coast. Installation and service, maintenance of offshore wind farms are a specific challenge for technology and economic operation of a wind farm. Service vessels have to be operated nearly 24/7 to get sufficient amortization from the wind turbines. Therefore, special fast service vehicles for installation as well as for maintenance are required. So-called inertial and optical-based ship stabilization and motion control systems are used for that. Experimental and proposed wind farms. There exist also some wind parks, which were mainly built for testing wind turbines. In such wind parks, there is usually from each type to be tested only a single wind turbine. Such parks have usually at least one meteorological tower. An example of an experimental wind park is Osterode Wind Turbine Test Field. For some time, airborne wind farms have been discussed. Airborne wind farm is a group of airborne wind energy systems in the same location, connected to the grid in the same point. By region, Australia, Canada, China. In just 5 years, China leapfrogged the rest of the world in wind energy production, going from 2,599 megawatts of capacity in 2006 to 62,733 megawatts at the end of 2011. However, the rapid growth outpaced China's infrastructure and new construction slowed significantly in 2012. At the end of 2009, wind power in China accounted for 25.1 gigawatts of electricity generating capacity, and China has identified wind power as a key growth component of the country's economy. With its large land mass and long coastline, China has exceptional wind resources. Researchers from Harvard and Tsinghua University have found that China could meet all of their electricity demands from wind power by 2030. By the end of 2008, at least 15 Chinese companies were commercially producing wind turbines and several dozen more were producing components. Turbine sizes of 1.5 megawatts to 3 megawatts became common. Leading wind power companies in China were Goldwind, Dongfang Electric, and Sinovel, along with most major foreign wind turbine manufacturers. China also increased production of small-scale wind turbines to about 80,000 turbines in 2008. Through all these developments, the Chinese wind industry appeared unaffected by the global financial crisis, according to industry observers. According to the Global Wind Energy Council, the development of wind energy in China, in terms of scale and rhythm, is absolutely unparalleled in the world. The National People's Congress Permanent Committee passed a law that requires the Chinese energy companies to purchase all the electricity produced by the renewable energy sector. European Union. The European Union has a total installed wind capacity of 93,957 megawatts. Germany has the third largest capacity in the world with an installed capacity was 29,060 megawatts at the end of 2011, and Spain has 21,674 megawatts. Italy and France each had between 6,000 and 7,000 megawatts. By January 2014, the UK installed capacity was 10,495 megawatts. But energy production can be different from capacity. In 2010, Spain had the highest European wind power production with 43 terawatt-hours compared to Germany's 35 terawatt-hours. Europe's largest wind farm is the London Array, an offshore wind farm in the Thames estuary in the United Kingdom, with a current capacity of 630 megawatts. Other large wind farms in Europe include Fontaine-le-Cogillac wind farm near Constanta, Romania with 600 megawatts capacity, and Whiteley wind farm near Glasgow, Scotland, which has a total capacity of 539 megawatts. An important limiting factor of wind power is variable power generated by wind farms. In most locations the wind blows only part of the time, which means that there has to be backup capacity of conventional generating capacity to cover periods that the wind is not blowing. To address this issue, it has been proposed to create a supergrid to connect national grids together across Western Europe, ranging from Denmark across the southern North Sea to England and the Celtic Sea to Ireland, and further south to France and Spain, especially in Higuera, which was considered for some time the biggest wind farm in the world. The idea is that, by the time a low-pressure area has moved away from Denmark to the Baltic Sea, the next low appears off the coast of Ireland. Therefore, while it is true that the wind is not blowing everywhere all of the time, it will always be blowing somewhere. India has the fifth largest installed wind power capacity in the world. As of the 31st of March 2014, the installed capacity of wind power was 21,136.3 megawatts, mainly spread across Tamil Nadu state. Wind power accounts nearly 8.5% of India's total installed power generation capacity, and it generates 1.6% of the country's power. Pakistan is developing wind power plants in Jhimpir, Garo, Ketabandar and Bin Kashim in Sindh. The government of Pakistan decided to develop wind power energy sources due to problems supplying energy to the southern coastal regions of Sindh and Balochistan. The Jhimpir wind power plant is the first wind power plant in Pakistan. The wind farm is being developed in Jhimpir by Zorlo Energy Pakistan, the local subsidiary of a Turkish company. The total cost of project is $136 million. Completed in 2002, it has a total capacity of 50 megawatts. Fuji Fertilizer Company Energy Limited is building 49.5 megawatts wind energy farm at Jhimpir near Karachi. Contract of supply of mechanical design was awarded to Nordex and Deskin Engineering Limited. Nordex, a German wind turbine manufacturer. In the end of 2011, 49.6 megawatts will be completed. Pakistani government also has issued LOI of 100 megawatts wind power plant to FFCEL. Pakistani government has plans to achieve electric power up to 2,500 megawatts by the end of 2015 from wind energy to bring down energy shortage. According to a USAID report, Pakistan has the potential of producing 150,000 megawatts of wind energy, of which only the Sindh corridor can produce 40,000 megawatts. The Philippines has the first wind farm in Southeast Asia, located northern part of the country's biggest island, Luzon, alongside the seashore of municipality of Bangui, province of Ilocos Norte. The wind farm uses 20 units of 70-meter-high Vestas V82 1.65 megawatts wind turbines, arranged on a single row stretching along a 9-kilometer shoreline off Bangui Bay, facing the West Philippine Sea. Phase 1 of the North Wind Power Project in Bangui Bay consists of 15 wind turbines, each capable of producing electricity up to a maximum capacity of 1.65 megawatts, for a total of 24.75 megawatts. The 15 onshore turbines are spaced 326 meters apart, each 70 meters high, with 41 meters long blades, with a rotor diameter of 82 meters and a wind-swept area of 5,281 square meters. Phase 2 was completed on August 2008, and added 5 more wind turbines with the same capacity, and brought the total capacity to 33 megawatts. All 20 turbines describes a graceful arc reflecting the shoreline of Bangui Bay, facing the West Philippine Sea. Sri Lanka has received funding from the Asian Development Bank amounting to $300 million to invest in renewable energies. From this funding, as well as $80 million from the Sri Lankan government and $60 million from France's Agence Française de Développement, Sri Lanka is building 2 100 megawatts wind farms from 2017 due to be completed by late 2020 in northern Sri Lanka. South Africa. As of September 2015, a number of sizable wind farms have been constructed in South Africa, mostly in the Western Cape region. These include the 100 MW Sia wind farm and the 138 MW Gouda wind facility. Most future wind farms in South Africa are earmarked for locations along the Eastern Cape coastline. Eskom has constructed one small-scale prototype wind farm at Kliphuil in the Western Cape, and another demonstrator site is near Darling, with Phase 1 completed. The first commercial wind farm, Coega Wind Farm in Port Elizabeth, was developed by the Belgian company Electrowinds. United States U.S. wind power installed capacity in 2012 exceeded 51,630 megawatts and supplies 3% of the nation's electricity. New installations place the U.S. on a trajectory to generate 20% of the nation's electricity by 2030 from wind energy. Growth in 2008 channeled some $17 billion into the economy, positioning wind power as one of the leading sources of new power generation in the country, along with natural gas. Wind projects completed in 2008 accounted for about 42% of the entire new power-producing capacity added in the U.S. during the year. At the end of 2008, about 85,000 people were employed in the U.S. wind industry, and GE Energy was the largest domestic wind turbine manufacturer. Wind projects boosted local tax bases and revitalized the economy of rural communities by providing a steady income stream to farmers with wind turbines on their land. Wind power in the U.S. provides enough electricity to power the equivalent of nearly 9 million homes, avoiding the emissions of 57 million tons of carbon each year and reducing expected carbon emissions from the electricity sector by 2.5%. Texas, with 10,929 megawatts of capacity, has the most installed wind power capacity of any U.S. state, followed by California with 4,570 megawatts and Iowa with 4,536 megawatts. The Alta Wind Energy Center in California is the nation's largest wind farm in terms of capacity. Altamont Pass Wind Farm is the largest wind farm in the U.S. in terms of the number of individual turbines.